In this video, we will look at an example where we compute the definite integral graphically. Recall, we found that if we know a function's derivative, that is, capital F prime equals little f of t, then the change in capital F from t equals a to t equals b is the integral from a to b of f of t dt. And we earlier found that this is also the area under the graph of little f of t from t equals a to t equals b. We will use this in our example. Suppose that the rate of sales of movie tickets, in tens of thousands of tickets per week, is graphically given by s prime of t, where t is the number of weeks since the movie was released. Notice here that s prime of t keeps track of how fast we are selling the tickets, where s of t is the total number of tickets sold since the movie was released. What we want to find is how many tickets will the movie sell in the first 4 weeks, and how many tickets will the movie sell before it leaves the theater. Notice that both of these questions are about the number of tickets sold, which is s of t, but we are only given information about how fast we are selling the tickets, s prime of t. So we will need to use the integral to solve them. For our first question, we want to know how much s of t changed in the first 4 weeks. That is, how much s of t changed from t equals 0 to t equals 4. So this is the integral from 0 to 4 of s prime of t dt, which we know is the area under the graph of s prime of t from t equals 0 to t equals 4. In the second question, we want to know how many tickets will the movie sell before it leaves the theater. Since the movie leaves the theater after 8 weeks, this is asking what is the change of s of t from t equals 0 to t equals 8, which we can find as the integral from 0 to 8 of s prime of t dt, which is the area under the graph of s prime of t from t equals 0 to t equals 8. Let's now answer these questions the best we can. Remember, for the first one, we are trying to find the area under s prime of t from t equals 0 to t equals 4. It's important to point out that since we can't find the exact area, we need to approximate it by counting the number of rectangles under the curve. We will start by counting our full rectangles. We have 1, 2, 3 of them. We now need to approximate the area of the rest of the space. We can see in this region that we have roughly 2 full rectangles. And we can approximate this last piece as being about half of a rectangle. So in total, we have about 5.5 rectangles. But it's important to realize that each rectangle has height 4 and width 2. So the area of each rectangle is 4 times 2, which is 8. So the area of the shaded region is 8, the size of each rectangle, times 5.5, the approximation of how many rectangles we have, which gives us 44. So we have that the area under the curve from 0 to 4 is approximately 44. But remember that these are given in tens of thousands, so the number of tickets sold is 44 times 10,000, which is 440,000. Bringing this back to our original question, we can now answer that the number of tickets sold in the first 4 weeks is 440,000. Now let's approach our second question similarly. Again, we want to find the area under s prime of t, but now we are going from 0 to 8. Again, we need to approximate this by counting the number of rectangles under the curve. To start, we will use that we already approximated the number of rectangles from 0 to 4 to be about 5.5. And then over the time interval from 4 to 8, it looks like we have about 3/4 of a rectangle. So in total, we have 6.25 rectangles. Again, remember that the area of each rectangle is 8, so the area under the graph is 8 times 6.25, which is 50. Since these are also in tens of thousands, we get that the number of tickets sold is 500,000. Bringing this back to our original question, how many tickets will the movie sell before it leaves the theater? We now know that it will sell about 500,000 tickets. In closing, I want to point out that we took information about the derivative s prime of t to find information about the function s of t, the number of tickets sold. This is the importance of the integral.